Hello everyone, my name is Li Hu. I will introduce the paper submitted to iMeta. The title is Distinct Responses of Airborne Abundant and Real Microbial Communities to Atmospheric Changes Associated with Chinese New Year. Airborne microorganisms, including pathogens, have become issues of global concern due to their threats to human health. The airborne microbes would be affected by surrounding environmentals, such as the sources of airborne microbes and human activities. Microbial communities typically contain a few abundant but many rare species. Previous studies have demonstrated the distinct responses of abundant and rare species to environmental changes in soil and water. However, how the airborne abundant and rare species respond to environmental changes is still unclear, especially at our scale. Thus, we propose three questions. First one, how about the high time resolution dynamic of airborne microbes? And the second two is, how about effects of environmental changes associated with Chinese New Year on abundant and rare species? And the third one is, whether the human activities during Chinese New Year would increase the threat of airborne microbes. We sampled airborne microbes at 2-hour scale and analyzed the bacteria and fungi communities using high-throughput sequencing. The results showed that the airborne microbes were grouped as before, during, and after Chinese New Year, and the time group affected abundant bacterial subcommunities significantly, but not rare bacterial species. When plots indicated that most of bacteria and fungi ASVs were group-specific, and most of shared ASVs among 10 groups were identified as abundant species. Further, we analyzed the effects of day or night and time series on abundant and rare subcommunities. The results showed that abundant bacterial subcommunities during Chinese New Year were affected by day and night, which only affected rare bacterial species before Chinese New Year. Series of hours affect abundant species during and before Chinese New Year. We determined the ASVs with significant difference between time groups using LEFSE. The results showed that most of ASVs with significant difference between groups were identified as abundant species. RDA and PRDA indicated that environmental changes would affect airborne microbial communities, especially abundant subcommunities. In the environmental factors affecting airborne communities, inorganic pollutants played the most important roles. We found that stochastic processes predominated in the assembly of abundant subcommunities, while the assembly of rare subcommunities mainly contributed by deterministic processes. Human activities during Chinese New Year would affect the assembly of bacteria and fungi communities and would increase the threat of airborne microbes to human beings. Through the research, we got the following conclusions. Firstly, we explored the hour-scale dynamics of airborne microbes. And secondly, we found human activities during Chinese New Year changed the air pollutants, which distinctly affect airborne bacteria and fungi, and increase the threat of airborne microbes to human health. The last one, we found that abundant species were more sensitive than rare ones in responding to environmental changes. Finally, please submit your work to iMeta. That's all. Thank you.